Hello guys and gals, welcome to our game development mini show. I hope you're not having as hard of a time understanding what we're doing here as I do. So we had a major breakthrough yesterday because, as you may or may not know, we had a very serious problem with the screen jolts. Elements of our game were uncontrollably moving up or down on the y direction. They're changing their y position, the position on the y-axis, and I didn't know what was the cause for this. I mean, I never changed the position on the y-axis, but yesterday, as we were playing with some settings of our Cinemachine plugin. If you don't know what Cinemachine is a virtual camera plugin with a lot of useful tools. Most of them, which I don't understand, but in our case here, we can set our camera to simply follow the spaceship. Can follow the spaceship, so we don't have to write code for that. As you can see, the spaceship has a certain speed, and the camera follows it. We set the settings right here in Cimivcam 1. Set the follow. You set which element to follow, and it follows the spaceship. You also have to set the lookat property also. But if you look right here, this virtual camera, the Cinemachine camera, also adds a Cinemachine brain to your main camera. The Cinemachine component. As you can see, the update method, one of the properties, which is set in the fixed update Unity function, which is the physics update, which usually may happen more often than 1 frame per second, and the next property, which is the blend update method. So let's see what this translates to. Cinemachine blend update method. So we should resolve the blends and update the main camera after all our physics and update of the main objects of the game are finished. So it's set to late update, as it should be set to late update, but I hadn't set it up to late update up to yesterday. It was set to fixed update, and as you can see, if we set it to fixed update, the blockers will start to jolt. You can see, let's select one of them. First of all, the spaceship, as you can see, it has a non-linear speed, jolts. See, it jumps back and down, up and down. You may say that of course, it may be caused by the low frame rate, but as soon as we set it up to late update, see, it has a smooth motion now, even with this low frame rate of 2 or 3 frames per second. So this is the cause. We need to let the computer, the processor, perform all the update functions, and then in the late update function, which is called after all the update functions are called, the last, then we can perform the camera calculations. Okay, so let's change it to fixed update. Let's check the first blocker. Okay, so we have this one here. As you can see, it moves, but you will see right here, as you will see right now, it jolts. You can see the Y position changes from 0 to whatever new value it chooses to change to. You don't want that. We want it stable on the Y-axis. And as you can see, if we change the main camera Cinemachine brain blend update method to late update from fixed update, as you can see, the blocker stabilizes itself, and you can see right here in the far up right position, the Y-axis no longer varies, it stays put to 0. No more blocker jolts, no more spaceship jolts. Everything is smooth, even though we accelerate. You see? So this is very, 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 very good. If your game is fluid and linear, even at this low frame rate, that means it's working. I mean, the game is only 5 frame rates per second because I'm working with a slow computer, only 8 gigabytes of RAM. So the memory is almost full. No strain on the microprocessor, but the memory DDR3 only 8 gigabytes, and a slow graphics card, almost non-existent. Of course, it will output only this many frame rates, but if I test it if you test this game on a mobile Android phone, it will output 60 frame per second constant speed. But this is maybe the only benefit of having and working with a less performant computer. Having these low frame rates allows you to find out the initial problems of the code of the game, of the linearity, of the fluidity, and other issues in the initial stages of the development. Okay, so we solved this problem. Maybe the most important breakthrough up to now is blend update method late update setting in the Cinemachine brain. Eliminates all the blocker jolts. So they move as they're supposed to move now. It's good. It's good. Okay, let's see what problem we had. Other problem. Positioning. Okay, no. Misalignment issue needs to be solved. So we have these two types of blockers which do not perform the movement as they're supposed to. So let's see. which we're talking about. Okay, this one. Rotative robin. So which is row error? The row error. Rotative bounce. The last one. Okay. So let's see the last one. Robo. Okay. Robo. So this is the one, and we initialize the variables here. Maybe here and here. Okay. No. Compute local cards. This is mostly comment there. All these updates that we're doing here are physics updates. They're only performing the modifications of the transform object of our game object. So okay, update bouncer, because they only do that. We access them in the fixed update function, which is the physics update, with no connection with the update function, which is responsible for the graphical updates. So this one works at least it seems it works as it's supposed to work. This one works round robin. Round robin works or doesn't work as it's supposed to work. Round robin. Let's see. Rotating bounce. Rotative bouncer works good. It works good. Rotative robin. Round robin. Okay. So this round robin, this one doesn't work. So let's see. This one, the round robin. This one we have to fix. So update round robin. This one, it's right here. So let's fix this one. If we fix this one today, it's good. Made progress. So how is this blocker supposed to rotate? Well, we have the rotative robin blocker, which is this second one. As you can see, it rotates around this center point here, the barrier. But it also rotates around its own axis. So we want, so this is a rotative robin. The round robin only rotates around this center axis of the barrier right here, where I have positioned the cursor, with of course variations on the y and x axis. You can position it more to the left or to the right or upwards or downwards, but you get the idea. The blocker, wherever it's positioned, it will rotate around that positioning of his. And of course, depending on that where that point is, So let's suppose it's here in the center of the barrier. In the properties right here, settings files, we have a setting called Robin radius. Let's see our next to last blocker. Let's see which is the property. This one, Robin. The Robin radius, the fifth position. So 1, 2, 3, 4, 5. 45. 1, 2, 3, 4, 5. No, 0, 1, 2, 3, 4, 5. The Robin radius 0.7. Okay, 0.7 Robin radius. Trigger angle, no, trigger angle. This is 1, 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. The radius is 3.5. So on the radius of 3.5, it will rotate around that point. And let's see if this happens with our next to last blocker. Does it happen? No, it doesn't happen. It just rotates around its own axis, which is not what we want. So something's amiss here. The code is not correct. So round robin, of course. The rotate blocker around robin. Let's also open the old Java code to see if we translated it the wrong way. Okay. Also, we need to open the new document, test window. Okay, so let's compare it with our method that works, and this is the rotative robin function. You see, this one works all right. So we should only copy the method that rotates the blocker around this position right here, surrounding this point. So update rotative robin. This is okay. So we have this, right? You have to copy this one. Okay. How do I have I don't. Maybe if I use this one, no, doesn't work. Okay. So we have to use this one. Update rotative robin. Update rotative robin blocker. Okay. Where is the Java code? Where is it? Here. Okay. No, update rotative robin. Not around robin. Okay. So we check if we can initiate expansion. No. Okay. And this okay. Lots of coding here. Once we start to hit the blockers, we'll have to add all these type of code, mesh expansions, and It will get a little bit complicated as we advance, but right now let's focus only on the mechanics. So we have this method, rotate blocker array. Okay, let's see. What's the problem? Why don't we have it? So update blocker, no. Also have it in Robin bouncer. Yeah, Robin bouncer. What else don't we? Robin bouncer. Master. Okay, good. So there's something wrong with it. Let's see what. Knock around there. Okay, so we have these accelerations. We have the blocker spread angle. Transform. Okay. Oh, it's simple, sort of. Let's see. Let's see. Okay. So we know what we have to change. Let's start. First of all, um, let's modify this one. I don't like how I don't like the ordering of this this code. Okay. After we change this, we will modify this. Okay. So we'll have to replace the transform rotate with the rotate around the method. Okay. Oh, this way. This way. Like it's more readable for me. This way. it's more ordered, more compact, even though it may not be for you. In a sort of way it isn't, but in another sort of way it is more ordered. So we have it this way, so we can read it a little better, hopefully. So you don't check for the angle here, you see. Just leave it this way for now. Sprite angle. So we're here. Sprite angle transform. Rotate around. Oh. Speed. Okay. So this is it. Okay. Right angle 90, 45. Okay, acceleration. 90, 45, acceleration 2, rotation speed, rotate around, of course. Gonna rotate around from now on. Now between 135 and 90 we have this situation. Rotate around, of course, again, but only this. Yes. Oh no, this game object transform. What's the difference? Okay, leave it right the way it is. Okay. If rotation speed okay, so this is 0f, of course. Game object transform. Nope, not like this. This one first. Set to degrees vector, and only that. Bizarre. Nothing else. Let's check this one. So if this one was 0f, rotate, we reset it. So very strange. We're gonna okay. Um. Mm, I'm gonna use this, of course. The 0 angle minus, okay. So this is it. Oh no. Nope. Rotate around. Let's check this rotate around function. Okay. So we'll use the angle is the last argument, of course. Oh, we'll still use rotate around. The rotate around, but it's not sec. It's okay. Rotate around, and will be rotate around with this angle. Okay, and it will reach its orientation properly, hopefully. Good. And set to degrees, set to degrees, right angle, else, okay. Else, it's a simple, just comment this. Okay, so this rotate by degrees. Okay. 2 to 5. Okay. Well, let's go. So it's good. Hmm. What? Let's go. 360, 315. Okay. Um. Okay. 360. Then set to decrease, but I also need to set this one. Okay. So let me put this one first. Set to degrees second. Rotate around. So rotate origin forward, and this one is 300 degrees minus right angle, and it's set after the right angle. Good. So we set it. Good. Okay. Bueno. Bien. I don't know what this overcatcher is. I don't know. I really don't know. So we don't know. We don't know. Just comment this. Rotate by degrees. Okay. So this one is the forward working one. It should be quite all right. Sprite angle and rotate around. Hopefully it will work. Let's see our initial. Okay, so it's positive. Let's test it because it's not a negative type of movement, so it should work. Oh, we have a problem. We had a problem. What's the problem? Okay, let's jump to the problem here. Huh? We don't see it. Where the hell is it? Rotative Robin. This one had, let's check the blocker chords. Oh, this one not here, not here, not here. Rotative robin, round robin. So let's check our origin. Look at the origin. It says right here, transform parent. So the cause is this one. First of all, this should not be the origin. Rotative robin. This should be the origin. But this should not be the origin either. What the hell? Oh no, yes. The origin. Blocker game object transform parent transform position. Blocker game object transform parent transform position. X, Y, Z. So it's the middle, of course. Okay. What's the problem here? Need blocker position. So we set the blocker position plus relative plus radius sec. But ladies and gentlemen, you should always also have a blocker, a robin radius non-sec. I mean, maybe we have, maybe we haven't, but that's correct. So this one we should have added. So now we should have something going on. Let's see. Is it working? Is it doing what it's supposed to do? Hmm? Oh yes. Let's make the radius bigger a little bit. At least we... Let's see. Let's accelerate the spacecraft a little bit. So you see, maybe the descent angle is not quite good, but we have a working robin. Okay, you see? Okay. Okay. Let's make the angle bigger. Angle. So robin radius, the fourth. If it's the fourth, I don't know. Let's make it 0, 1, 2, 3, 4th. Let's make it 4. Or even 5. Let's make it 5. Okay. Let's see. Let's... Something's quite not right with this round robin, but we're starting to see some action. Okay, so this is it. Okay, let's see what the problem is. So good. We have this one. Mm-hmm. Maybe this one. I don't like it this way. What's the change? 135. Original. Okay, this one. Bit compare, transform. Maybe this one should not. Oh, yes. Okay. Else, transform it around. Okay. Let me check something. So this is rotate. Okay. Local. Transform rotate, rotation speed or delta. Okay. Rotation speed or delta. Why don't we have this here? Should have this here. Oh, that's one main problem. Rotation speed. Or delta, my friend. Or delta. One thing. We should multiply it by delta. And we should do this in the right part also. So the but not only this. Sprite angle, of course. Delta. Okay. So more delta. Okay. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. But yeah. So you see why we have this problem here? Of course, it was a problem caused by something. We had a rotate where we shouldn't have rotate method. Okay. Rotate around. Okay. Oh, delta. Delta. Huh? Okay. One. So this should work well, better now. It should work better now. Okay. And now to accelerate. And it accelerates. Okay. It jumps right there. I don't know why. Let's modify something. Now, of course, it's some weird acceleration. So let's make it 3, 5, 25, 25, 25. Let's have it this way, and we'll cancel the delta of the acceleration. Here. Begins to accelerate. No, accelerate again, then stop. Oh, why does it do that? I don't know. Why does it do that? Okay, it jumps from one angle to another way. Let's see why. 45, 0. Okay. Excel Q1, Q2, Q3, 1, 2, 3, 4, okay, 5, T1 again. Uh-huh. Uh-huh. Huh? Maybe we should put this again here. Hmm. Forgot to multiply by delta here. You see the jump, delta, delta. Um, if it's less, let's see. I mean, we should cancel this also. Okay, so let's check it out now. Okay, let's see. So it begins to rotate. Okay. Starts to accelerate again. Okay. So it performs quite well. Perfect. This is just perfect. Now we should change the angle for this rotative robin. Okay, so it works. Good. Now let's do something else. Let's cancel these delta accelerations. I mean, you only have one delta. We don't need another one. Let's comment these out. See, and no. Yeah, and put it like this. Or don't, I don't know. Should I or shouldn't I? multiplied by delta twice. It's unnecessary. Let's see how it behaves. Huh? No, it's good. It's good. It's good. So, okay, it's good. It's good. Very good. We're just gonna leave them as they are right now, and we'll modify them further. Maybe cancel the accelerations, the delta time multiplication with acceleration, and we'll only multiply by delta time the speeds. So we'll have no unnecessary delta time multiplications. No, it's good. It's perfect. You see? It rotates exactly as it's supposed to. Okay, we solved this one only. So, but we also have the negative function. So let's rewrite. So this is and let's write this one also. Okay, let's write it. I mean, oh, when we have this neg, neg, we're gonna neg. Okay, this one, this is a different type of method. We put this variable in a but I need to sort out this mess. Of course, we'll sort it out. Let's sort out this mess first, and we'll write the function. So, okay, this is a mess. Wood. Yes. Hmm. Well, if it works, it works. So okay. Hmm. Hmm. Okay. Mhm. Okay. Just arrange the first part. Oh, we haven't done anything yet. Okay. So it's all right. So rotation speed, not overcomplicated. So this rotation speed acceleration. So Mister, this is if this is rotation speed or rotor delta, and this rotation speed or rotor delta. Only need to put this here as in a rot, and that's it. And this is only a rot. Okay, if we're doing something, let's be concise. Good. So this is it, right? This is the right way to do it in this variant. Okay. Good. Okay. Okay. One hundred and 100 good. So this oh okay, rotate around, rotate around, of course. Speed, rotate around. So no rotate around. Yeah. comment this, now rotate around, no rotate, so only this. Okay, well, this is good. Next one. Okay. $225. Okay. Oh. So we have this angle. Rotate around, rotate around, rotate around. Okay, and right here only have the rot. Okay. So first of all, let's see if we have any syntax issues. And if we don't, we're gonna change the direction of rotation of this right here. Gonna make it -1. Okay. So we have it move it this way, but as soon as we'll change direction by turning this one into a -1, you should see it rotate clockwise. Oh. uh, huh? Not what we wanted. So let's see why. Let's see why. So error. Um, Hmm. Uh, minus 40. Okay. Minus 28. Minus 76. And it suddenly 40, 90. Okay. Okay. This rotation is transform this origin vector today. Alright, rotate it. Oh, Okay, this is the problem. So this is rotor delta, this is rotor delta, this is rotor delta, this is rotor delta, and this one, and this one, and this one. So let's see if hopefully this is the problem. It should be. As you can see now. Oh, as you can see now, no. It transformed itself into another type of blocker. Okay, so it almost behaves as it's supposed to behave. Huh. Mhm. Hmm. Oh. Um, so it reaches this point. Rotation. Okay. Or delta. Right angle rot. Rotation no. Else. Chemistry transform. Rotate around this origin. We have another rotate here. Rotate around. Set degrees, rotate around. Rotate around. Nope. Rotation to add. Rotation to add to vector z. Vector z. Add vector z equals. But it's not add. It's a assignment. So it's an assignment, not an add. Neg. Why does it? Maybe here. Maybe the position. Maybe this one is the. Huh? Let's comment this stuff out and save and see if this is the problem. Probably, most probably yes. This was the problem or not. Let's see, will it work or will it not work properly? Acceleration now. Then deceleration, yes. And now, good. So that was a problem. Okay. Okay, let's note this. So we need to check all methods for proper set names. Also test. need to cancel all part-time or Excel multiple actions. Use Excel reducers to jobs instead global. Okay. We solve all this. We solve all this. Solve all the above. We move to mesh blocker stoppage. I click or touch. Then mesh deploy blocker expansion. Then deploy. Okay. So I need to solve Robin also misalignment. Okay, so today we corrected the round robin blocker also. As you can see, it's rotating properly. Very good. It's all working smooth. And in the next few days we'll evaluate, modify here and there these rotational functions, and then finally we can move to. It will be quite interesting to write this code again in C# Unity. So it's all good. In the next few days, the next few weeks, also we'll have to start to chisel our spaceship controls. We'll have to make her this baby shoot, make her shoot, make it spit its venom towards these blockers, and it will eventually start to look like a game, little by little. Okay.